Hello everyone. So I am going through CFA Level II derivatives reading number 29. In that we will talk about options and binomial model. A little background about myself. I have completed MBA in finance. I work in valuations. It has been 3 years. Uh, like I'm in my third year, I would say, not 3 years, but yeah, I'm in my third year of job. So yeah, I have studied this options and binomial model during my MBA as well, and right now in CFA. So let's start with it. So first of all, just the basic background of options, very basic understanding if someone doesn't know. So if we talk about stock options, let's say, so there are two options, call option and put option. Call option gives us the right to buy the stock at exercise price after let's say 1 year, 2 years at a predetermined price in the future. So that predetermined price is called exercise price or strike price. Put option gives us the right to sell the stock at exercise price in future. So we will denote exercise price through X because that is how we denote in CFA. Okay. So let's just understand the basics. Let's say the stock price today is 50. We buy if you buy a call option and the strike price is $45. Call option for 1 year. After 1 year, if let's say the stock price is $55, you have bought call option, which means it gives you the right to buy the stock at $45. So if the price is $55, you will exercise your option and buy it at 45, and hence it will be called that the option is in the money, which means it is benefiting you. Second scenario, let's take if the price is $45. It's exactly the same as your strike price. So doesn't matter if you buy it from the market or you exercise your option. So it is called at the money. Third scenario, if the stock price is $30, which is less than your exercise price. So would you rather want to buy from the market at 30, or would you exercise your option and buy the stock at 45? You would definitely buy it at 30 from the market. You will not exercise your option, and hence it is called out of the money option. Now let's talk about put. So put option gives us the right to sell. So this the same, if we take same scenario, everything will get opposite. Okay, if the stock price is 55, so it means that you can sell the stock at 55 in the market, and this option gives you to sell this gives you the right to sell it at 45. So obviously you would want to sell it at higher price, and therefore this will be uh, out of the money option for you, because you will not exercise your option. You would want to sell it at 55. At 45 you are indifferent, it becomes at the money. At 30, if the market price is 30, so you would want to sell it at 45 because that is higher price obviously, and therefore it becomes in the money. This were the basics. Now moving on to the chapter. Binomial models. So why binomial? So binomial means there is two options. Either the stock price can increase or the stock price can decrease. Based on this, binomial models is built. So let us understand one period binomial model, which means we are taking only one period from now. Let's say t is equals to 1. At t is equals to 1 it will expire. Taking the example that currently the stock price is $30. Now there are two scenarios. In either the stock price can increase or it can decrease. Let's say that it increases by 33.3%, or it will decrease by 25% after 1 year. So first look at this. Don't look at this. What should I say? Let me just erase it. Yeah. Paying attention here, 33.3% the price can rise. So 30 into 1.33, but it will become around $40 after 1 year. If the stock price goes down, it will be 30 into 1 minus 0.25 because it will go down by 25%. It will become 22.5 after 1 year. These two scenarios are there. Now, what is the probability that the stock price will increase and what is the probability that the stock price will decrease? Obviously, the probability is not 50-50. It is not 50-50. The stock might be performing good. There are more chances that the stock price will increase in 1 year after 1 year, and there are less chances that the stock price will decrease. So we will need to calculate the probability of the probability that the stock price will move up or the probability that the stock price will move down. And there is a formula to do this. To calculate the up move probability, the formula is 1 plus RF minus D upon U minus D. So U is your up move factor, which is 1 plus percentage up. D is your down move factor. How much will it go down? 1 minus percentage down. Pi U is your probability of an up move, and this is the probability of the down move, which is 1 minus probability of up move. So this is the formula how to calculate the probability of up move. Okay, that what is the probability that the stock price will increase? 1 plus your RF minus D upon U minus D. So in the previous example that we had here, let's consider that the risk-free rate is 7%. So we'll calculate the up and down move probabilities here. It will be 1.07 minus down factor was 25% down. So the down factor will become 0.75 upon 1.33 minus 0.75. Let's calculate this. This gives you approximately 55%. So there is 55% chances that the stock price will move up, and hence therefore there is 45% chances that it will go down, because obviously there are two outcomes. So the probability of a down move is 1 minus probability of an up move. Now we have come to this probabilities. Now let's calculate the call option value. it's the call option. Okay, so it was 30, the price increased to 40 and can decrease to 22.5, T0, T1. Now the probability of this happening is 55%. 55% probability, and the probability of this happening going down is 45%. We know that. Okay, at t is equals to 1. Now our strike price was how much? Wait a second. Okay, so we have not decided the strike price, the exercise price. So let's say that the exercise price is also 30. Let's say that the exercise price is also 30. Okay, so here, which is this is call option plus. Okay, because it is the stock has increased in the value, so it will be C plus. What is the benefit, the payoff that the call option is giving you? In the market, the stock price is 40. You can buy it at 30, which means 10 rupees profit. You are in 10 rupees profit, right? Let's talk in terms of dollar only. So you are in $10 of profit. Therefore, this payoff C plus at time 1 is of 10. Here at C minus, what is the payoff? The market is giving you the stock at 22.5. The option is giving the stock at 30. We will not exercise the option. Yeah, we will not exercise the option, and hence the payoff is 0. There is no negative here because obviously we are not exercising the option, so payoff will be 0. Now we want to calculate C, that what will be the price, the value of call option, the price of call option at t is equals to 0 today. So this would be, it will give you $10 profit, but the chances of this $10 profit is what? 55%. So it is 10 into 0.55. Let me just write 55% plus, here it is 0, so 0 into 45%. This gives us 5.5. This is the value of the call option today. Now, so this was about one period binomial model. Now, this is, sorry, this is not at today. One thing, yeah. So this is not today. This is at, you will also have to discount it, right? So let me just add it here itself. Whatever the price is coming, whatever this is coming, it's at T1. Or let us just write one second. What just happened? Yeah. Let us write at T1. Year 1, this is the value, but you will, to find the value today, we will have to discount it, right? This is 5.5 at year 1. To find the value today, oh my god, sorry. We would have to discount it at the risk-free rate. So, value of the option today is equals to 5.5 upon 1.07, because the risk-free rate was 7%, discounting it for 1 year, and this gives us 5.14. And this is the value of the option, call option today. Now, moving on to, okay, so let's just also take the same example for put. Okay, let's just take the same example for a put option. Same scenarios, $30, exercise price is also 30, but it's a put option, not a call option. Here it becomes 40, here it becomes 22.5. This is 55%, 45% probability. Now here, if you can sell it at 40, would you like to sell it at 30? No. So here the value will be 0. The payoff of put option is 0. Here, if market is giving you the option to sell it at 22.5, but you can sell it at $30. So here it is, the option is in the money by $7.5, right? Now same thing we will do by multiplying with the probabilities. We will calculate the value of the put option in one period. Okay, this is time 1, time 2. So value of put option in one period is 0 into 55% plus 7.5 into 45%. Let me just calculate it. This gives us 3.375. So this is at T1. Here at T is equals to 0, the value of the put option would be 3.375 upon 1.07, and this gives us 3.1542. This is the value of the put option. Now, moving on, let's talk about put call parity. So for put call parity, first let us understand what is a fiduciary call. Fiduciary call means long the call, okay, buy the call option plus invest in zero coupon bond. So there are obviously no interim interest payments. Invest in zero coupon bond of face value equals to your strike price or your exercise price. Okay, so what is happening here that you are investing in zero coupon bond. So if we are investing in zero coupon bond, we are doing long call. So long call is we are buying the right. Okay, so we are buying the right to buy the call, buy the stock at, let's say, X dollars, and here you are investing in zero coupon bond of face value is equals to exercise price. So after a year, when you will see at here, if your option is in the money and you want to buy the stock at X, and you have also invested in zero coupon bond, at year one, the bond issuer will give you exercise price, so you will get X, and you will use this to buy the stock. Simple, because we have the right to buy it at X. So we will get it from the bond issuer and then we will pay it to buy the stock. That is called fiduciary call. Now, another thing in put call parity is protective put. What is protective put? Here you will long stock. You are buying the stock and you are buying the right to sell the stock, long put. So here you will buy the stock, okay, buy the stock and sell it at the strike price. Simple. Protective put is what you're buying the stock today, and whatever the exercise price is, you will sell that stock at that exercise price in the future. The put call parity states that fiduciary call is equals to value of fiduciary call is equals to the value of protective put, which means fiduciary call, we were doing long call, so it was C0 plus we were investing in zero coupon bond. So if at year one you are getting X, so today you will get PV of X, and why X? Because we are investing in a zero coupon bond where the face value is equals to exercise price of the option, right? So the value of fiduciary call would be C0 plus PV of X, and this is equals to protective put, which is long stock S0 plus P0. Now from this equation, one second. I wanted to remember this equation. Now from this equation you can create a synthetic call. How? C0 is equals to S0 plus P0 minus PVX. Simple. which means what you are going to do to create a synthetic call, you are going to long the stock, long put means buy the put, and short zero coupon bond. So this is put call parity. We just need to remember what is a fiduciary call, what is a protective put, and a put call parity states that fiduciary call is equals to protective put. Moving on to two-period binomial model. I would say let us directly understand it with an example. I will just first make a normal diagram so that you understand what is two-period binomial model. This is the price today, stock price today. Stock price can increase or it can decrease. Okay, at year 1, this is at year 0, this is at year 1. Now further at year 2, if the stock price is increased, then again it can either increase or it can decrease, S plus plus or S plus minus. If the stock price has decreased, it can either increase or it can decrease. This is two-period binomial model. This is going to be the same. S plus minus or S minus plus, it's the same thing. Now let us take one example and understand it. Let's say today the stock price is $50. The exercise price is 45. Up move probability is 1.25. So sorry, not probability, the factor by which it can go up is 1.25, which is 25% return. The value of stock can increase by 25%, or d 0.8, it can decrease by 20%. So either it can decrease by 20% or it can increase by 25%. The risk-free rate, let's take 7% itself. Now, what is the value of the call option? We have been given everything. We have to take out the value of the call option. So first of all, let us calculate the probabilities. Let us calculate the probabilities. Probability of an up move would be 1.07 minus 0.8 upon 1.25 minus 0.8. This is 0.6. So 60% is the chances that the stock price will increase, and 40% are the chances that the stock price will decrease. Now, let us first make the binomial tree for stock price. Okay, a very small binomial tree just for the stock price if we make. So it's $50 in the starting. It can increase by 25%, so it's 50 into 1.25. 50 into 1.25, this gives you 62.5. Or 50 into 0.8, which gives us 40. Okay, then again same 62.5 into 1.25. It can it can increase by 25%, so that remains same. Okay, that will remain same, that it can increase by 25%. So this will be 62.5 into 1.25, which is 78.125, and it can go down by 20%. So 62.5 into 0.8, which gives us 50. Similarly for this, if the stock price is 40, it can increase by 25%. So 40 into 1.25 will give us 50. And if the stock price is 40 and it can further decrease by 20%, so it will become 40 into 0.8, which is 32. So this is the 2-period binomial tree. This is at time 0, this is at time 1, and these prices are at time 2. Now, value of option at expiry. So what we have to do, like in one period model also, in one period model we did now that we calculated the value of option at t is equals to 1, that means at expiry, and then we discounted it to the present day. Here also the similar thing will happen. Here, whatever the price is, whatever the value of the stock is, whatever the payoff is, you calculate the payoff, you discount it by one period and bring it till t1. So this here one value will come and here one value will come. When we will do the example, we will get to know. So it's basically these two knots, we are using these two knots just like a one period model. Consider this as a one period model, one period binomial model. Consider this as the one period binomial model. Let's just consider this, right? So these two knots will give you one value which you will discount and bring here. Similarly, this will act as a one period binomial model. This will act as a one period binomial model. And these two values, these two will give you one value which you will discount and bring here. And then you will get two values here, which you will further, you will solve for this using the probabilities, and you will further, using these two values, you will come at one value. You will come at one value, you will discount it, and you will bring it at time t0. So that is how it will happen. Let's look at the example and understand. Okay, so I would rather create how to do it. Let's just do values at value of option at expiry, that is t is equals to 2, right? So sorry, C++ would be what? 78.125 minus 45. 45 is the strike price, right? 45 is the strike price. So this gives us 33.125. This is C++. C plus minus or C minus plus, it is the same thing. It is 50 minus 45. This gives you 5. Then there is C minus minus, which is 32 minus 45. But this is negative, so you will take 0 out of the money. Right? So, to better understand, let me do one thing. To better understand this, let's just do it like this. C minus plus. When the value goes down and then it increases. So it is 50 minus 45, 5. I know it's one and the same thing, but it will help us understand. C minus minus is, it's, what should I say, maximum of 0 or 32 minus 45. This is how you denote it, which is 0. Now you will take this as we discussed earlier. You will take this scenario. This scenario is what? This scenario is up scenario. right? It first increased and then it either increases or decreases. So you will take one scenario at a time. Take one scenario at a time. One scenario. Apply probabilities and calculate value at t is equals to 1 as we discussed. Similarly, for this, same thing will happen, right? Same thing we will do for this, that apply probabilities and calculate value at t is equals to 1. Then at t is equals to 1, we will again have two values. We will have these two values. These two values, which we have calculated using this step. Okay, we'll have these two values. Again, we will apply probabilities on these two values. And bring them at t is equals to 0. So this is the scene. Okay. Now let's do the calculations. C plus would be, that is at t1. At time 1, your C plus would be 33.125, which we got here, 33.125 into up probability. The up probability was 60%. So this into 0.6 plus 5, the payoff was 5. The chances of it happening is 40%. Whole divided by 1.07, because we are discounting for one period right now. This gives us the value. Let me just calculate. This gives us the value 20.45. C minus, which is basically these knots are there, right? This is one, then this is another knot, then this is as plus plus, as plus minus, as minus minus. So here this is C plus, C minus. So we are calculating these values. Okay, this is, sorry, we are calculating these values, and this is 20.45. This here, this value, this will come C minus, and then using these two values and applying probabilities, we will come at C0 or just C. Okay, so C minus will become 5, the other was 0. So 5 into 60% plus the other payoff was 0 and the chance of going down is 40%. 1.07, this gives us 2.8. Now, this is at t is equals to 1. At t is equals to 0, we will again do this. C is equals to 20.45, because this was for up. So this is the chance, the value C plus, when the value of the option when the stock price increases, and the increase probability is 0.6. So 20.45 into 0.6 plus 2.8 into 0.4, and discounting it one period to bring it from T1 to T0. And this gives us approximately 12.51, which is the value of the call option. So one thing I want to say, that this was the binomial tree for stock price. This was the binomial tree for stock price. Now we can create the binomial tree for sorry now we can create the binomial tree for option price. The same example. What is the price in the beginning? 12.51. So it was 12.51. Then it became 20.45 and 2.8. 20.45, 2.8, and then it was 33.125. Here it was 5 and here it was 0. Time 0, time 1, time 2. So this is two-period binomial model. That's it for today. If this is helpful, please like, share, and let me know if this is helpful so that I will make more videos, and then we can cover American options, because there is a difference between American and European options. Then further on we can cover, because American options can be exercised early. So how, if they are exercised early, then early exercise price. We can cover that. We can cover hedge ratio. Then there are different, then there is interest rate option, which is here in the syllabus, interest rate option. Then there is obviously Black-Scholes model, BSM, Black-Scholes-Merton model, and various scenarios or various versions of it for options on dividend paying stocks. Then there is BSM model on options on currencies. Then there are options on futures, options on I think fixed, options on interest rate. There are options on swaps. All these things are in reading number 29. So let me know if you want to cover it further, if you want me to cover it further. Thank you for watching. If you have watched it completely, if I have come till this point, which means I am thankful and grateful. Thank you.